So, being that this is an optimization question, let me walk you through the steps real quick. Okay? So one number is 10 larger than another. So guess what? X would be y plus 10. X is one number. Y would be the other.
Wait, what? Oh.
You can start anywhere. Something. Yeah, if you do it, if you have it opposite, that's fine. Doesn't matter. But find these numbers if the sum of their squares is to be a minimum. So, so x squared plus y squared. That's the minimum sum that this is what we're trying to optimize, right? So yeah, I like working with x too. So let's say that y is x plus 10, right?
Yeah.
And we'll say that x is going to be the smaller number then. So we have x squared, and what does y equal now? Well, y equals x plus 10. So we're going to let that squared as well. So this is now the sum explicitly defined in terms of x. Okay? So you need to get two equations into one. The two equations would be here's one and here's another one, okay, or this one. So we've got an equation for the quantity that we're trying to optimize, all in terms of only one variable. Great. Now we need to take the derivative of this. So that's going to be equal to 2x plus, now you could expand this out if you want to first, or you just do chain rule. That's going to be 2 times x plus 10 to the power of 1 times 1. So this is going to be 2x plus 2x plus 20, right? So that's going to be 4x plus 20. So that's what your derivative equals. Now, if there's going to be a max or min, or something that we can optimize, it's going to be at a critical number. So we want to find out where the critical number A doesn't exist, boys, or B equals to 0. So there is no value for x that's restricted. So there's no critical number where this doesn't exist. So you want to let this equal to 0. 0 equals 4x plus 20. When you solve for x, you get x equals negative 5. Now remember, that is just one of the numbers, right? And as a matter of fact, x would be the smaller number, y would be the larger number. So you have to figure out y, because find these numbers. Y is positive 5. Negative 5 plus 10 is positive 5. So these are the two numbers, but the question also asks for the minimum sum. So, boys, x squared plus y squared is the sum. And these are the values that are going to provide us a minimum sum. Okay? Now, if you think about the nature of the question, how do you know that this is, so this could be 25 plus 25. The sum is 50. Now, how do you know this is a minimum? This is the one other question you want to ask yourself. Well, if we have two numbers, and one number is 10 larger than the other, and it would be unreasonable to think that there would be a maximum. Well, okay, 1 billion, right? Square that, and let's square 1 billion and 10, and that's going to be my maximum sum. Oh, wait a minute. If I did 2 billion, squared that, and then added 2 billion and 10 squared, that's going to be even larger. So as the numbers get larger, there is no maximum sum, but there would be a minimum sum. So this critical number right here gives you a minimum sum. So those are the two numbers. There's the sum. Plug them back into one of the original equations.